Okay, last lesson of Unit 5. We're going to connect the ideas that we've learned about previous lessons. So connecting variation. Variation, remember, is a change if something is good. Slope and first differences. So all of those are connected, and we're going to find out how. And you should have a pretty good idea already. For the top little space there on page 22, we're going to take a handful of notes. The slope of a linear relation. Let's pause. Let's talk about this word relation. What does relation mean?
Equal to.
So there's some kind of equation where there are two variables and one variable relates to the other one. Or they both relate to each other, really. Okay, they're not necessarily equal. They might vary directly or they might vary indirectly. Okay, if you're not sure what those mean, you have some work to do before Wednesday. What does it mean that this relation is linear? If you were to graph, if you were to graph the relationship, it would form a line. That means as the x's go up by constant rate, like 1, 2, 3, 4, 5, 6, 7, and the y's, if the y's go up by a constant rate, like 3, 6, 9, 12, 15, 18, etc., then we can trust that it is a linear relationship. Okay, so if we were to graph it, it would form a line. Table of values would also show us, because the y values would go up by a constant rate. And off the top of your head, can you remember what the first differences would be doing?
Quick question.
No, answer my question first. First differences, what would they be doing in a linear relationship?
Going down. Going up. Opposite. No.
So the first difference is this column over here.
Oh, you're minusing. You're subtracting.
Adding.
No, you're subtracting.
Multiplying by
Subtracting over here, yep. So you've got 6 minus 3, 9 minus 6, 12 minus 9. What's the answer?
They all make a straight line in a
3,
graph.
3,
Do we copy
3.
that?
So the first differences are
Congruent.
constant. Thank you.
Ruined.
Okay. What's true about the slope?
It goes up.
Or down.
Straight.
It's what?
Positive.
Might not be, might be negative. In that example, it was
line.
positive. It's a line.
It's
But
going.
the slope of the line is constant. Thanks.
Is it going
Slope of a linear relationship, of a linear relation remains constant. Okay? And you've answered this question already, so hopefully you can get it again. The first differences of a linear relation are constant. More notes about the slope. The slope, represented by what letter? M. M. Always. The slope M of a line can be calculated by dividing, so we're looking like a fraction. What goes in the numerator and what goes in the denominator? Okay, so another way to say those things.
The slope.
The change in y over or by the change in x. This is a good little review lesson, I think. So you should have some space to do this. So our formula, m equals what? Rise over run. Which equals, and maybe we'll just work across, take up less space. Tell you what, we'll work down and we'll draw a little graph over here, okay? So This is, what was the other words that we used up above here?
Changing X and changing Y.
Which goes where?
Changing Y goes up.
Change in y on the numerator over change in x. And then, yep, we had a little equation to help us out.
Y2 minus y1.
y2 minus y1
Isn't that the
over
square?
x2 minus x1. Okay?
Do you need the Y on the one there?
This one is also sometimes written, right, delta y over delta x. Okay, so if you want some
The
space,
square thing.
you can rewrite that delta y over delta x, where the triangle represents the Greek letter delta.
This will not be on the test.
It very well could be. You've learnt it, so you should know it.
I mean, like, well, you put delta in.
Maybe. Okay, let's use the rest of your space here to draw a little diagram. So just draw your y-axis and a horizontal x-axis, and we'll label those x and y. And it doesn't really matter the numbers on the side. Let's just not write any numbers on the side. Let's draw a line
Constant.
segment from here to here. And again, it doesn't really matter what you call the coordinates of each point as long as you're consistent. So if this point down here, and do your coordinates above the point, if this point is x1, y1, then this point must be what? x2, y2.
Why do you do them above?
Because I'm going to draw a triangle underneath. And then, if we want to calculate the slope, we need the rise and the run. So the run is the horizontal distance traveled. It's the distance between x2 and x1. And the rise is the vertical distance traveled. It's the distance between y2 and y1. And they form a right angle triangle, where this distance, the horizontal distance, represents the run. And to determine the run, what do we need to find? What do we need to do? If I want to find out how far it is from here to here, what do I need to do?
Count.
Why can you guys sleep?
No,
Y-
you minus
well,
y1 minus y2.
Careful. Is this the y-axis or the x-axis?
Oh, x.
Okay.
Never mind.
So you take x2 minus x1. Okay? Over here, we have the rise. And in order to determine the rise, it's the distance from here to here. What do I need to do?
y2 minus y1.
Very good. Okay? Do you guys have a little bit more space down here?
No.
Not at all?
Yes.
So
Yes, sir.
if you don't have any space down there, you can head to the top. Otherwise, you need just one or two more lines. You can write small. The equation of a line has the form. What's the equation of a line look like?
Line segment.
Y equals. Oh,
2x.
No, mx plus b.
Y equals mx plus b. If you don't have that memorized yet, you absolutely must memorize that. Okay? Y and x are the variables. It's right here on your graph, right? X is an axis and y is an axis. So y and x are your variables. They depend on each other. M is the slope calculated by rise over run. And b is the initial value, or
The constant.
the constant, nice. Or you can think of it as the place where this line would cross the y-axis. Okay?
Sir.
Good. And that's what we're writing basically right now. The equation of a line has the form y equals mx plus b, where M is the slope, and B is the vertical
Constant rate.
intercept.
What?
All that means is B is the place where
It crosses
the line
Y.
would cross the y-axis, but they use vertical because it doesn't necessarily have to be the y-axis. If you're talking about earnings or pay or fees, then it would be the f-axis or the p-axis or the e-axis. Okay? It also happens where x equals 0. It's the value of y where x equals 0. Okay, another way to think about it. Good. Okay, example 1 is again dealing with fuel consumption. We've talked about an example like this before, but the graph that you see on page 22 shows the relationship between the volume of gasoline remaining in a car's tank and the distance driven. So you can see as you drive, the volume of gasoline in the tank is going down. Okay? So in A, all we need to do is calculate the slope and describe its meaning. In order to calculate slope, let's get down our equation. What do we need to do? Well, slope is what? What's the equation for slope, guys?
M equals B x mx plus B.
No.
No.
Rise over run.
Oh, the door.
Okay, what else? How else could I write this?
Delta y over delta x.
Okay, and let's get to the one that we actually want to use here, folks.
Change in y1 thing.
y2 minus y1 over x.
Y1 minus Y2.
Okay,
I don't know.
good. Now here's a problem. We need y1 and x1, and we need x2 and y2, but we don't have any points on our graph, or do we? What points do we know on our graph?
We have 0 and 65.
Okay, so good. So
It's
let's do
0.
this. X1,
And 500.
Y1. So that's the amount of gas that they're starting with after not driving at all is going to be 0.65.
It's not right on the 500.
Okay?
It's 400.
X2, Y2 is going to be what?
0, 6, 500.
Careful, get your axes correct. Get your points correct.
0, 500.
500, comma 0.
Mm.
Okay, the first number is always the x number or the horizontal axis. The second number is always the vertical y-axis. Okay? Well, we have our 2 points. Can we use our equation now? Yeah, for sure. Okay? Y2 minus Y1 is 0 minus 65.
Negative
And actually, they're
Still confused.
oh yes. So
Special.
it doesn't matter. We're gonna do it this way. Good. 0 minus 65, and the run 500 minus 0, which gives us negative 65 over 500, which reduces to, both of these are divisible by 5, so we're just going to reduce it to negative 13 over 100, and we'll leave that as our slope. Okay? Now what does this mean? What does this fraction tell us?
Every time they fill up the gas, how far they traveled before filling.
If they travel 100 kilometers or however many whatever goes by, then their volume will go down by 50%.
The more they drive,
Good. So it's 13 liters of fuel for every 100 kilometers. Okay?
Used to be.
So hold on, let's get a sentence here first, and then we can.
that's really good.
The rate
Is that actually?
of change
Yeah.
No, it's not really good.
Yes.
It's not terrible, but it's not really good.
Like
The rate of change of the volume of fuel
Like $2,000.
in the tank is negative 13 over 100 liters per kilometer. So the car uses approximately, or an average of, that would be better, of 13 liters of fuel for every 100 kilometers driven. If you want a comparison, I have a older Ford Edge, and it uses slightly more fuel than this. So like a pickup truck would use more than this, but a regular car would use quite a bit less than this.
slightly less than
Can I go to that?
Okay, B says determine the vertical intercept. So
60,
No, 14.
65.
okay, the vertical intercept. So take this note. The vertical intercept
Is 0.
is the value of V. Remember, because we're talking about volume in a gas tank. So it's the value of V when D equals 0, when distance is 0. So it's the value of the vertical when the horizontal is 0.
So 65.
So yeah, in our case, it's up here at 65. So V equals 65. And then look at this point. Therefore, B equals 65. Why is that true? They have the same definition. In our equation, y equals mx plus b,
Because it's a constant.
b is the constant. It's the value where x equals 0, which in this case is 65. Okay?
No, wait.
So then C, we have enough information. Write an equation for this relation. So an equation is always in the form y equals mx plus b. And when we have a finished equation, y and x will still be in it, but m and b will be replaced by actual values. So what are the actual values of m and b?
M is 13, right?
No, m is...
Oh, negative 13 over 100.
Okay, so we've got y equals negative 13 over 100 times x plus
Plus 65.
65. Okay?
The
Now-
constant thing is not going down by 65, is it?
No.
Sir.
No,
Yeah, that's what I thought
it's
B was.
going down by negative 13 over
M
100.
is the slope.
M is the slope, m is the constant of variation.
Where did
Good.
we get 65 from?
The top.
The top. Come on.
That's where we started after we had not traveled any distance yet.
Oh yeah, because P is the one.
Sorry, it's how much volume was in the tank after we've not traveled any distance yet. Okay? Now, this also can be represented using the variables that we started with in our graph, right? What we're actually doing, the y-axis is actually volume, right? So the volume is going down 13 100ths every,
65.
no, every kilometer,
Oh, every kilometer, yes.
and we're starting with 65 liters.
And then pass it over.
So in the first example, we gathered some information from a graph. In the example 2, we're going to gather information from an equation, and we're actually going to graph it. It says make a table and graph the relation y equals 2x minus 5. Hey, does y vary directly with x or
No.
indirectly?
It varies with the whole thing.
No,
together.
y
No,
equals
it does. It
or
varies.
y has a relationship
What
with
Jake
x.
said.
Is it direct or indirect?
Indirect.
It's indirect because there is a constant, there's a minus 5. So if it varied directly, it would go through 0, 0. This one is not going to go through 0, 0. You know what point it's going to go through when x is 0? Negative 5. It's going to go through 0, negative 5. Good job, guys. Okay, so make a table. An x, y table. And what points do you think we should choose for x? Because we get to choose the x points.
No, 1, 2, 3, 4, 5. It says 7, 8.
Yeah, usually we'll start at 0.
1, you said.
Because 0 gives us really important information. I never said start at 1.
Yeah, sorry, you said yeah.
Yep.
And then what? The other side's 5.
1, 2, 3, 4. That should
Zero
give us
said
more
zero.
than enough information. And now, since y equals
Negative 5.
2x minus 5, we can calculate which y goes with each of these x's. So you're right, here we've got negative 5. What about if we put 1 in for x?
Negative 4.
Are you sure? 1 times 2 is,
2.
minus 5 is.
Sure about that.
Negative 3.
What if we put in 2 for x?
Negative 2.
Negative 1.
Let's do some math here, folks. Stop trusting patterns, and because you're not following any sort of pattern anyway.
Negative 1.
2 times 2 is 4, minus 5 is negative 1. Without calling out the wrong answer, do this one correctly, please. Put in 3 for x. You get 2 times 3 is 6, minus 5 is positive 1. The last one, positive 3. Good. And now we do have really helpful information to graph this thing. I'll just quickly sketch a graph, but basically look at your points so you can see where to draw your axes, because you're a little bit, the vertical axes you're going all the way to negative 5 and positive 3. So in x-axis we started at 0. So on your grid, draw something that kind of looks like that. Will allow you to fit all your points. So here's x and here's y.
Okay. Screwed her up a little bit.
And we can go negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3. And here, 1, 2, 3, 4, 5. Okay, you have your axes drawn? Looks, and your numbers in, looks something like that.
Wait, what? Oh, I just did my part on
And now we can plot our points. So we know that when x is 0, y is negative 5. So that point is 0, negative 5. That's right down here. 0, negative 5. 1, negative 3. So x is 1, y is negative 3. 2, negative 1. X is 2, y is negative 1. Go ahead and draw, add your other last 2 points, and draw a line through those points. Okay, your graph should look something like this. And because it's a line, watch what you have to do. Yes, we only checked the coordinates for the x values 0 through 5, but this line, this equation, actually will produce a line that goes forever and ever and ever and ever. So we put a little arrow on both ends. That says, hey, this line goes forever, we're just not drawing it. Alright?
We'll be here forever.
So we drew, now next thing we're going to do is calculate our slope. Now, often, so far, when we've been doing the slope of a line, we've been doing a line segment. But we know that the slope is going to be constant for the whole line. Okay? So we can actually choose any point on the graph to calculate our slope using our point. So I could draw my right angle triangle to get my rise over run. Right? Here's my rise. And here's my run.
So 1 over 2.
So I could just do it from 2 points here. Right? I could just do it from my very 2 points here. This is the point. What are these 2 points? This is the point 2, negative 1. And this is the point 1, negative 3.
So every time it's going 1
Okay?
across 2 up. or 2 down.
So here we go. We can calculate if you have room here or underneath, wherever you have room, go for it. But we can calculate our slope, which is rise over run, which is the change in y with y2 minus y1 over the change in x, x2 minus x1. And now I can just put in my values. y2 is -1 minus y1, which is -3, over x2, which is 2, minus x1, which is +1.
So is that a 3 in that bracket?
Yep, -3.
And -1.
You got it. So we've got -1 minus -3.
-4.
Wrong.
Oh.
Positive 2.
-1 plus 3
-2.
is +2. And 2 minus 1 is 1. So our slope,
Is a half.
no, it's certainly not.
Oh no, it's 2 of them. Right? Not that.
Now we chose to do it between these 2 points. Do you think I would have gotten a different slope or the same slope
Same.
if I did it from this point way up here to this point way down here?
Same.
No.
Would have got the
Because of the first
exact
difference.
same slope because the slope is constant. Boom. Okay, way to go, everybody. That's it. So you have found the slope, and guess what? Look at the slope. +2. Oh, look at the slope in my original equation. +2. Good thing that worked out. Okay. Oh, look at all my first differences. -3 minus -5. Oh, +2.
What a coincidence.
-1 minus -3. +2. 1 minus -1. +2. Okay? Slope is constant. There it is.
Right.
Also, we just connected the slope with your first differences. Okay? Before we take on example 3, we have a couple of notes to take on page 23. Right in the middle, it says a relation can be represented in a variety of different ways. Okay? A mathematical relation can be described in 4 ways. It can be described using words. Using words. Okay, you don't have to write this example, but an example of this would be y is 7 less than x. Okay, y is 7 less than x. The second way it could be represented is using a diagram or a graph. Using a diagram or graph. You don't need to draw this, but in the case of y is 7 less than x, that would be a graph where y varies indirectly with x, and it's actually going to be 7 less than x. So that would cross the y-axis down here, but it would still go up every time x goes up, y by 1, y goes up by 1. So it still has a slope of 1, +1. That's what these words would look like if we graphed it. Okay? The third way that we can represent it is using numbers. Using numbers. I want to say this is kind of, I think what they're trying to get at is a table of values here, using numbers. So if we used numbers, we would say, okay, let's look at what's happening when x is 0, when x is 1, when x is 2, and then you do a few more, but I'm just doing a short one. And they would say, okay, y is 7 less than x. So if I have 0 and I have 7 less than that, I must be at -7. If I have 1, I must be at -6. If I have 2, I must be at -5, because y is always 7 less than x. And the fourth way that we can represent them, which is what we're working toward being able to use really easily, is using
Equation.
an equation. So what's the equation here? If y is 7 less than x, you'd have y equals x minus 7.
Why would it have to be x first?
Because you have 7 less than x. So you're starting with x and taking away 7.
Why couldn't you
just write 7 minus x.
Because it's not 7 minus x. That would be starting with 7 and taking away x. You're not doing that. You're starting with x and taking away 7. Yeah, very important to get those correct. But Maddie, you might not have been looking here when I was pointing here. 7 less than x means you're starting with x and going down 7. Start with x, go down 7. Start with x, go down 7. Still didn't watch. Okay, example 3. This is a word problem, just like you could easily have on a test or an assignment, which is coming your way shortly, or practice problems. We have Jacques. Please read with me. Jack delivers advertising flyers. He earns $25 per day plus $9 per 100 flyers delivered. What is the relationship between? What are we comparing here? What are we?
Equation.
Yeah, so we're gonna develop an equation. Yeah.
By
mx
using
plus
numbers.
y equals mx plus b.
It's gonna look something like y equals mx plus b. What are the two variables?
25.
No, not what are the numbers.
9 and
Oh.
100.
Not what are the numbers.
Flyers and
Flyers delivered
And
And
money.
and money earned. Okay, so Jack's pay and the flyers delivered. Do they vary directly or indirectly?
No,
Directly.
Directly.
Indirectly.
No, wait.
Indirectly.
How do you know?
Depending on how many
Because
flyers
it's
does it go
flyers
through
he
the
delivered.
source.
Is everyone else?
This starts with 25.
Because he starts with $25.
That's what I said. It doesn't go through
Okay.
the source.
It does the origin. The origin. Yeah.
That is so
Good. Good. Okay. This is an example of how to use words to describe a relation, okay? We have words here. He earns $25 per day plus $9 per 100 flyers delivered. But we can represent it in different ways as well. We could do it using numbers, like in a table of values. So the first one we're going to do here is you're going to have 3 different ways, guys. So you're going to actually want that little space that you have, you're going to want to split it into thirds. Okay, but don't actually do it physically with a line right now. Let's just do a table of values and try not to take up too much space with it. So you have number of flyers. I'm putting that in our left column because it's our independent variable. And the money earned, his earnings, which is in dollars. We're going to use the letter E to represent it. And for flyers, we're going to use the capital letter F to represent it. Well, number of flyers, because it varies based on 100 flyers, every 100 flyers. So we'll go start at 0, and then we'll jump right up to 100 flyers, 200 flyers, 300 flyers, and that's enough for this example. Now, what are his earnings going to be? Don't call it out. Think about it. Put your hand up. What are his earnings going to be if he delivers 0 papers? $25. Okay, and I don't need to write the dollar symbol in there with it. I can just keep the numbers because I already represented that it's all going to be measured in dollars in this column. How much money is he going to make if he delivers 100 flyers? Jaden. $34. It says $24, and then plus 1 unit of 100, which was 9 extra bucks. Jacob, what's my next? For 200 flyers?
Which would be...
And everyone else should be thinking about it as well. Basically, he's doing another 100, so he gets another 9 bucks. So we got 43. And the last one?
52.
52. Okay, add 9. Good. So there we have it with numbers. Okay? Another way we could represent it is using a graph. Okay? So if we were using a graph, we'd need axes here. And we're not going to worry about any negatives because he's not going to deliver negative papers and earn negative money. But here, what would we label our axes? Because it's not going to be X and Y.
Dollars and flyers.
Good.
F and E.
Good. F and E. And where are we going to put...
F is that one and E is that one.
No, E is up
X is
and F.
So because F is independent, the number of flyers, and E depends on F, it's going to be our vertical axis.
It's always the one on the left of that
is on the bottom.
Correct. This is always going to be your horizontal. Okay? And this is always going to be your vertical. Now, let's think about numbers. The earnings that we did went up to $52, so I'll go up to 60. Cut it in half-ish for 30. 40, 50, 20, 10. Here's 0, right? And the number of flyers, we went up by 100, 100, 200, 300. And now we can plot the points that we know. We have 0, 25. We have 134, approximately there. Yours will look better than mine, I hope. We have 200, and after 200 flyers, he earns $43. And after 300 flyers, he earns $52. And you get your ruler out. You draw a beautiful straight line through your points. Now in this case, I'm not going to extend my line past this line because he's not going to deliver negative flyers, but what do I have to do to this end of my line?
Draw an
Oh,
arrow.
draw
An
an arrow,
arrow,
because I'm going.
because it can keep on going and going and going.
Practice problems on the back
Okay.
of the page.
Nope,
That's not
we're
another example.
not done yet.
Can I say
Okay.
I just wanted to clarify that.
In this example, guys, I'm just going to quickly draw you a little rise over run. As you're graphing, you're thinking, okay, a run of 100 and a rise of 9. Each step is like that. Rise over run, which tells us our slope. And the third way that we can represent this
equation?
is an equation. So we know that our equation is going to be y equals mx plus b, but we're not actually dealing with y and x. We're dealing with e and f, and we're finding out that our slope is our constant of variation. So it's going to be m times f plus b, which is our initial value. Okay?
25.
So earnings, well, why don't we figure out the slope first? What's the slope? Rise over run?
100 over 9. So 9 over 100.
9 over 100. B equals, what's our initial value?
25.
25. Good stuff, guys. So now we can plug those values in. We have E equals 9 over 100 times F plus 25. Again, it's partial variation because it does not go through the origin. It has an initial value of 25. Calculate our slope. The slope represents his rate of pay, which is $9 per $100 flyers. And yeah, good to go. So your practice problems are on the very back page of your booklet. Go for it.